Hello everyone. So my talk's about finality in Corda, or reliable finality, and it's called Lessons from the Field. It was triggered by some lessons from the field. It's mostly about things I tried out. So let's get started. One thing first, I would like to know who here has hands-on experience in writing Corda apps or working with Corda, or is it all technical people? Because it's going to be a bit technical. Let's see how we go. So let's start with a quick recap. What is finality and why is it important? And the concept of finality in Corda is that we ensure that a transaction gets verified, notarized, and then recorded with all the participants of the transaction, ensuring that we adhere to the principle of I see what you see. So basically we have everyone has the same view of a transaction that they were part of, which is kind of the central promise of a distributed ledger. It's like the point why we're doing this. And the steps are that we verify the transaction, i.e. we check its invariance and that it's all correct. Then we send it off to the notary to have it notarized if that's required, i.e. if we consume any states, the notary checks that it's not double spent, that if that succeeds, the transaction needs to be recorded on the note, and all the consumed and created states need to be recorded as such. And then it gets sent out to the lists of involved parties, so everyone has the same state of the ledger as in regard to this transaction. What finality does not do, it's nothing to do with agreement between counterparties. It does not collect signatures. All that has to happen beforehand in the business logic of the actual Corda app. Finality is really just about notarizing and recording the transaction so that once it's agreed, we have the same view on the Corda app. The way how finality is done in Corda has evolved a bit over time. So obviously it's been part of the original Corda, very first prototypes. Originally it was like a subflow you would invoke, and we'd have a finality service on each node that would receive the transactions. For Corda 4, this has been changed slightly so that not all the states will be recorded, only states that are relevant to a party that basically needs to store it. And also we introduced an explicit receive finality flow that you would call on your counterparties. So only counterparties that are part of a transaction in a Corda app and are actually expecting to receive states would receive them. Everyone else would not even look out for them. And we changed the way how we invoke it. So we have an inline flow now that takes an explicit list of sessions where to send the counterparty instead of the node working out where it should go, which gives the Corda app author, the Corda author much more fine-grained control over who actually gets to see a transaction and the states, which improves privacy and avoids some potential bugs and privacy leaks. And we currently have a new change that's probably going out in Corda, in the next Corda version, that improves the handling of errors that can happen during finality and make sure that the ledger stays consistent even if something goes wrong, which had a few issues. How does it technically work? You call a subflow, it's called finality flow. You pass it a transaction that is ready to be recorded, that has all the signatures it needs, it has all the agreements it needs. And you also pass it one or more sessions where it should broadcast, like counterparties that were involved that should receive the states and the transaction that is part of this flow. And the flow then basically calls a few functions. It calls verify on the transaction to make sure that it's actually a valid transaction. If that succeeds, it sends it off to the notary, and then if that succeeds, records it, and then basically just loops over the sessions you passed in, and sends off the transaction, including all the states, to all these sessions. And what the counterparty does, it calls a receive finality subflow with the originating session as argument that just waits to receive a transaction that has been notarized and exactly. There's a slight problem that this is blocking, but for technical reasons, we do not send it to ourselves. So basically, if the counterparty is ourselves because we have like a mix-up or something, and we wait for that, it'll just block forever because we don't send it to ourselves. So we have to add like an if statement around the receive thing. It's just like a technical gotcha you have to be aware of when writing Corda apps, that otherwise Corda app can block itself by calling finality on itself. So the question is now, what can go wrong with finality? Obviously, the transaction verification can fail, but that's fine. That just happens. If someone tries to do a stupid transaction, it'll fail. It's not a problem. We just roll back, and everything's back to the state before we started the transaction, because that's just how the transaction model works. All the states will be unspent everywhere, and it's all good. Obviously, the notarization can fail if states have been spent already. We've mixed up the input states, or we missed a time window. There's various conditions where notarization can fail, which is also not a problem for consistency. Like, we roll back and we're at the state we were before. It might obviously be a state for your app or your business logic that we have unspent states or spent states that we think are unspent, but nothing has gotten worse here. Like, this transaction didn't cause any extra problems with that. However, once the transaction has been notarized, it must be recorded, because what happens otherwise is that the input states of a transaction have been stored as spent on the notary, but if we don't record that locally, in our world, they're unspent, they're unconsumed. So we now have states that are unconsumed on our sides, but we can't spend them because the notary thinks they're already spent, it won't notarize them. So literally we have dead states that can't be used. Anything, any value attached to these states is lost. It can't be accessed anymore because we can't spend them. It's impossible. And that means ledger will be inconsistent because different nodes, i.e. notary and our node and everyone else, disagree on the status of these states. So the question is, what are the errors that can actually happen after notarization? So we might have database errors, like the connection to the database can fail, the database can run out of space, we can have other transient errors like deadlocks. What we don't really expect here and shouldn't have is like stuff like SQL syntax errors that should have been caught in testing that the SQL we emit at this point is actually valid. That would be bad, because that would mean it would never work. Other errors we can have is we can have network errors with broadcasting. So basically our counterparty is down, our network is down, some network component doesn't work. So basically we can record locally, but we can't broadcast to counterparties. Obviously the counterparty can have the same kind of database errors that we can have, like same list of errors. And most interestingly, there can be Corda code that can error at this stage. And you might yourself, wait, what? How? This is like a finality flow, like system flow. How can user code interact here? Well, unfortunately, it can. And we have to do a small excursion to Corda services and Vault service to understand how this can happen. Corda service is a class that gets annotated as Corda service. And if you bundle this in your Corda app, it will get instantiated when your Corda app is loaded. So it'll run, the class gets instantiated and is available on the service hub. In its init method, it can register a listener on the Vault. And in this case, we registered a raw update listener. Raw updates means it listens to updates as they're added to the Vault before the transaction actually gets committed. And basically, everything that we pass as a lambda to this raw listener gets run between adding states to the Vault and actually committing the transaction. That means they can interact with the database, for example, before it actually gets committed. And if they throw an exception, they can actually mess with the commit to the database, i.e. they can mess with the recording of the transaction that we're talking about. And another thing they can do, if they throw an exception, they can alter the state in the node, as in, if you don't handle exception in there, the listener gets unsubscribed. So anything that depends on this listener doing something will stop working once you throw an exception in there. So the nodes can be in a quite bad state depending on what your Corda app depends on, which is not a finality error, but can cause all kinds of problems. So I thought I'd mention it here. And yeah, so this is the point where basically users have seen this happen and have called support about this. So what we did, we started an investigation, what can go wrong there, and how can we fix it, how can we prevent this kind of stuff from happening, because it's not good. And to do this, I've written a Corda app that does all the things you really shouldn't do in a Corda app. I can throw errors in the most inconvenient places. It can throw database exceptions in Vault service. It can throw user exception in Vault service on storing a created state or storing a consumed state, all combinations. And also because basically on purpose made the database schema and the state not agree completely, it can also just blow up on actually committing the transaction to the database. All things you really shouldn't do in real code apps, but interesting to see what happens and how we handle these errors. And then I went ahead and wrote integration tests in Corda that basically run this code app in various configuration and trace the vault and the notary lock to see if they're consistent or inconsistent, and check whether flows finish successfully or finish unsuccessfully or get basically stopped and get stuck waiting for user interaction to rescue them. And in the last case, I've always written some tests to see whether we can actually rescue the transaction or the states by fixing the problem and rerunning the flow. So let's go through a few of the error cases we can have here. So notarization, we always assume here notarization works. It's all fine. The transaction is valid and notarized. But now we throw a database error while recording the transaction locally. What happens is that the flow will be passed to the so-called flow hospital, which is a class that basically gets the call stack and the exception from the flow and tries to figure out what went wrong and how to deal with this. And in the case of a database error, it might retry the flow, i.e. it basically goes back to the last Git checkpoint and tries to rerun from this point and see if it works this time, which can be helpful if you get stuff like a deadlock error in the database, for example, where a retry just will fix it, because probably the page that was locked is now unlocked and you can just go ahead. That might fail, or we might have an exception where retrying doesn't help, in which case we will keep the flow dormant. We'll keep it in the flow hospital and log an error, and basically we keep all the checkpoints, we keep the flow. A user can basically fix the problem, restart the node, and the flow should then rerun and basically fix the problem, and the states can be saved, the transaction can be saved. So we should eventually be consistent at some point. Obviously, while the flow is in the hospital, it might be inconsistent, but that's because the flow is kind of still in flight, so we have to wait for it to finish. We have to make it finish before we actually reach eventual consistency. The case is slightly different if the vault observer we added throws a user error that is not a database error and that the flow hospital cannot handle. Because in that case, the flow hospital doesn't know what to do. The exception might escape and actually kill the flow, shut down the flow. It gets rolled back, the checkpoints get deleted, and we end up in the case where stuff is notarized but not recorded because we just deleted everything and rolled back. It's like the worst case scenario, because that means we now have states that are notarized but unspent, so they're dead. They're just inconsistent, we have a problem. So don't do this. Don't throw user exceptions from raw vault observers, because it can lead to very, very bad states of the ledger. Next error case is we have a network error during broadcast, which basically we handle this quite gracefully. The initiating flow will just retry, keep retrying to broadcast to the recipient. And even if we shut down the nodes or kill nodes or stuff, because we use persistent queues for the peer-to-peer protocol, the message will eventually be delivered once all the network infrastructure comes back up. So literally this flow will be stuck or eventually complete, but we can't lose. I haven't managed to actually lose a transaction doing that. So we have some extensive testing where we randomly kill network components and bring them back, and we always get eventual consistency in that case. That's fine. That is dealt with. The next error case is we have a database error on the counterparty side. So basically, we record it locally. We send it to the counterparty accepts the message, and then explodes with a database error on trying to record on the counterparty. It gets handled similarly to the other case, so the flow will go to the flow hospital and the counterparty and can be saved. If you fix the database and rerun, it can be saved. Interesting to note here is, though, that the initiating flow does not get notified about this failure. So the initiating flow will happily tell you, I've broadcast to all participants, all is good, even though that's not technically true. It's just the way how Finality flow is working at the moment. Whether this can be changed without a breaking API change, we need to look into. It might be interesting to do that. It's work for the future. But we're basically safe, as in if we fix the database issue, we get eventual consistency. If we throw a user exception on the counterparty, it's a similar picture to the initiating party, that the exception again might escape and kill the flow. and the ledger will be inconsistent. This time it's consistent between the initiating party and the notary, but the counterparty is different. So basically we have spent the state, but the counterparty has not received it. And again, we've lost whatever the state is representing because no one's owning the state now. It's just gone, which is bad. So similar problem again. And on top of this, also the initiating party doesn't get notified this has happened. So we have no indication on the initiating side that we actually lost the state. It's just gone. And no one knows. If you don't know about this and don't carefully look at the log files, it's very hard to figure out where it's actually gone, why it's disappeared. So again, don't do this. Don't throw user exceptions from vault observers. That brings me to the end of the list of errors that I wanted to go through in the short time I have here. And just a quick recap of what we talked about. So database exceptions are handled by Corda. They're also mostly thrown by Corda, so that is expected that we handle them properly. They're either retried or they're kept in hospital and waiting for human interaction. We're also adding like a periodical logging in the next version. So basically, if you look at the log files, you see like a message saying like there's 3 flows in the flow hospital waiting for you to actually rescue them. You probably should do something about that, because otherwise, obviously, your ledger is not consistent while flows are in flight or in the hospital. Connection errors are also fine. That's not a problem. They will be eventually consistent if you bring back the connectivity. The thing is that throwing user exceptions from a raw vault observer is really dangerous because they can threaten the integrity of the ledger. You shouldn't do that. It's probably a bug that we let this happen. It's unfortunately not very easy to fix, so it's not going to go into the next version of Corda. We don't have a fix in the pipeline yet for this. We have to look at how to fix this. And the other problem is that any exception thrown from a vault observer can unsubscribe the observer, which is also a bug that we have raised the bug. We don't have a fix for that yet because, again, it's just technically not very easy, not very clear how you fix this in a very generic way that makes it hard or impossible to do this wrong. The workaround for these problems is, because obviously you have to go out of your way to cause these problems, they don't just happen if you write a simple code app. If you use a raw vault observer, be very careful what code you put in there and make sure you handle all exceptions. This also means if you use a raw vault observer, you can't deal with any cases where things might go wrong in there and you have to roll back. If you're in a raw vault observer, it's too late to roll back. You have to record. You can't, if you notice something's wrong there, it's too late, basically. You can't roll back. You have to carry on regardless. Otherwise, it becomes just worse. It doesn't become any better. A better alternative to raw vault observers is, for example, using the track by on the vault, which gives you a similar feed of transactions, but after they have actually been committed. So if you don't have to actually interact with the transaction before it's committed, so you get an atomic commit with your custom stuff and the transaction, which is difficult anyway, it's probably better to use something that is safe because it runs after commit. So even if it explodes, it doesn't threaten integrity because the ledger is is safe before your custom code gets run and you leave the Finality flow run on its own and basically your code runs after that, which is fine for most things where you just need to notify someone or update some other third-party system. It's probably fine to do this after commit. You don't have to do it atomically with the commit. And it's much, much safer, which is my conclusion is just the same thing again. Like, with the latest changes, Corda is fairly safe unless you actually mess around with raw vault observers. And if you have to use those, be very careful. Try to avoid them if you can at any point, which brings me to the end of my talk. Thank you.
Thank you for that. I think we do have some questions here on the app. The older version of Finality Flow relied on participants to know the recipients. Has this been changed? And do we have to explicitly specify the recipients now?
It has been changed. So the idea is that you're supposed to pass in a list of recipient sessions into the Finality Flow now explicitly to give more fine-grained control, because you might have participants in a state that might have an observer role that don't need to see the example, for example. There is a compatibility layer in there. So if you have an old code app that relies on participants, it kind of runs a compatibility layer that creates the sessions from the participant list, but that's not recommended to do. The recommendation is that in your Corda app you specify the list of sessions that need to see the results of this transaction.
Another question. If the transaction is not passed to the other participants, will the initiating party be notified about this, being the error and when it is fixed?
So if the transaction is not passed, you mean it's not transmitted, then we know that because we haven't transmitted it. If it's successfully transmitted but is not saved on the counterparty, the initiating party will not be notified of this. It'll just because there's no callback channel for that. It's literally just send and forget. We assume as soon, so we have on the networking layer, we have an acknowledgement, so we know that we know if the counterparty has actually received the transaction. If they don't receive it, they don't acknowledge receipt of the transaction, we know that, because then the network layer will not complete. But if they receive the transaction, but then subsequently fail to store it, we don't know. It just disappears, basically.
Does anyone have any more questions?
Have you ever considered doing some kind of soft record of a transaction before the notarization?
Yes, there's been talk about like a soft record or a two-phase commit where basically you pre-commit, then you notarize, and then you finalize the commit. This is, given the API stability promise and wireform stability promise of Corda, this is not trivial to implement. So we hope to implement this in one of the next versions. I can't promise when this will arrive though. Yeah, but that is like the end-all solution to this is basically pre-commit, then notarize, then finalize, then all of these problems just go away because you have always the point you can go back to. Absolutely, yes.
Well, thank you very much.
Thank you.